I'm going to tell you about a company called Accuri Cytometers. It didn't start out with that name, but that's what it ended with. And as I said, this is a case study in the early stage commercialization. This starts with an observation. Most of the best innovations start that way. The observation had to do with actually an industrial process. So if you're working with a metal lathe, you're cutting metal. In order to keep your tools from overheating, you need to run fluid over them. And that fluid, like most things that are liquid, can be contaminated with bacteria. And eventually, the bacterial load in the fluid is so high that as it's aerosolized, the person who's working the lathe is exposed to a high bacterial load, which causes their skin to break out and can, in fact, also cause lung problems. Also, the fluid has to be, since it's contaminated, it'll have to be changed out, and often the cutting fluid is toxic, which means it's expensive to dispose of. So this was an observation that was made that wouldn't it be better from an environmental standpoint and an industrial health and safety standpoint if we could figure out some way so that cutting fluids either didn't become contaminated or people knew that they were dangerous and needed to be dealt with. So this story goes back to the year 2000, and at that time we had an unmet need that was recognized. There's health complaints, costs, and lawsuits. And in fact, this starts out in lawsuits. There's a faculty member on campus, Steve Scarlos, who was actually being paid to consult in a lawsuit between the UAW and the big three manufacturers in Detroit over long-term complications to the lungs of folks who had been working on lathes. And so he was aware that this was a problem, and he had interest in environmental health and safety. And so he worked with a class that he was working on, a design class, to potentially come up with a device, engineer a device that could be used to test for bacterial load in industrial fluids. So this starts out in the machine shop, and then it goes to the mechanical engineering department here at the University of Michigan. That is not where it ends. The concept that was developed in the design class was a low-cost handheld device that counts bacteria suspended in industrial fluids. For those, how many people are familiar with a flow cytometer? Okay. So this was a miniature flow cytometer. It did not work like any flow cytometers that were available. There aren't any miniature flow cytometers that were available. But that was basically what it was going to do. It was going to be a cell counter using flow cytometry concepts. And the project was called microflow cytometer. And there was a demonstration prototype that was built with a College of Engineering seed grant. Okay, so this is the idea portion of the process. This is the light bulb going off. So how does it go forward from there? Well, the next 2 years, the idea was converted to an invention disclosure, which was given to the Office of Technology Transfer here at the University of Michigan. 2 patent applications were filed on that invention to secure the rights to that invention, and we'll talk. We're going to have a whole class talking about inventions and patents and how those rights work. We had a licensing officer in the Technology Transfer Office working with the inventors to evaluate both the patentability, and they decided it was patentable, and then the economic value. They decided there might be some economic value, so they went ahead and filed for the patents. So then they're at a position that a lot of our ideas end up at. They were in the Office of Technology Transfer. A patent had been filed, and there was a question about what to do next. Should we license this to an existing company? Should there be a startup created to manufacture and sell these devices? And to answer that question, and by the way, there's a CME, I'm going to be part of a CME panel next week. Is it next week? Or week after, that actually deals with exactly that topic. But to find a way through that, they needed input in the technology transfer office. So they needed help from entrepreneurs who had experience in this area. They needed technical capability, market analysis, and a competitive landscape. So they needed to understand, this is a good idea, but is it really good enough to go anywhere in the world? Okay, so this is where some entrepreneurs show up in the story. So there were there was an entrepreneurial team, Jen Baird and Colin Rich, who were working locally and had a startup which had kind of hit a wall, and they were looking for other ideas to create another startup around. And so they came to the tech transfer office and they said, hey, what do you have available? And the university tech transfer office presented them with several translational projects. This was one of the translational projects. And Baird and Rich eventually decided that they were going to try to take this forward, this microflow cytometer project. I happened to be working part-time in the tech transfer office at that time. I had just moved to Ann Arbor. My wife's on the faculty here, and I was keeping myself busy. So since I knew a little bit about flow cytometers, I said, well, I'll take this on. And so we got a grant, a gap funding grant that we were able to use to hire Baird and Rich as consultants to the university, and they began to investigate with me the business concept. So, 2004, so we're 4 years in from the observation that there's a problem and we need to do something about it. And in fact, this technology has been essentially laying fallow for a couple of years. So the patents were filed, but nothing was happening with them. There wasn't a company, the faculty member wasn't going to leave his position, didn't really have the interest or experience to create a company anyways. There weren't any companies that were interested in licensing this technology directly from the university, so existing companies. So we're 4 years in and we're trying to figure out what we can make out of this. And the early market research portion here, so we started brainstorming potential applications, and I'll go through that. The next step was to talk to potential customers about those applications and test the validity of the unmet need. We had assumed that there was an unmet need there. It seemed like there was an unmet need. And then we were going to investigate the markets and the competition in more depth. So there was 3 basic applications for this technology that we looked at. There was the original idea, which was an industrial application, and we were going to do something with this device to identify when cutting fluids were going bad so that they could either be perhaps treated or replaced, and therefore reduce the burden on the environment and on the workers. The next idea we had was around water safety. So if we had a little flow cytometer that can count bacteria, maybe we could use that to identify when bacterial loads are high at a beach, for instance, or there's a water safety issue, and we could determine right on the spot that the beach needed to be closed. The third idea was life sciences. So could we build maybe some sort of research grade flow cytometer out of this, or possibly a clinical diagnostic device? So what we did next was we went out and we asked people questions. These were basically 3 hypotheses, and we wanted to test them and see which ones were true. It could have been all 3 or none. So what we did next was we spent a lot of time listening. That was a fun, I got to experience what it is to be on the workshop floor where they're cutting metals. We drove around Michigan and we went to big companies that cut, medium-sized companies that are doing tool work, and small. It was actually a pole barn with 2 lathes, and it was warm that day, so they had the door open because there was no air conditioning in the pole barn. So we were investigating all of it. And we also talked to folks who are involved in doing water quality testing, both for drinking water as well as for recreational, beaches and ponds, that sort of thing. And we talked to some folks in the life sciences. And we spent a lot of time listening. And what we heard was that, to our surprise, that there really wasn't an application for this in industry. And the reason for that was that the very large companies, so they had a couple hundred people working on the floor, had lots of cutting machines running, fabrication machines. It's all running in a process line. They had figured out that cutting fluids was a way to reduce their costs if they could figure out how to not have to replace their cutting fluids. So they actually, in addition to running all their products through an assembly line, they ran all their cutting fluids through that same assembly line, recycled it back through a filter, and had someone in the shop who was trained to actually test that, measure the pH, measure to make sure that the fluids weren't being going off for various reasons, and treating it. So actively managing it the same way you would manage a water system in a city. So that was the large groups. The middle-sized groups had a solution. They actually every so often would take some of their cutting fluid, put it on a Petri dish, send that Petri dish through the mail to a lab, and then within a week they'd get an answer back as to whether or not the bacterial load was high, and then they would know what to do with the cutting fluids at that time. They would either treat them or replace them. And in the small shops, they just worked until Buddy's arms broke out, and when they broke out, that's when they changed out the barrel. And they went through 2 barrels a year, and the barrels were about $600 a piece. So even if they wanted to, even if they could figure out how to use it, at $600 a barrel, there was no way that we were going to be able to sell a product to them and make any money off of it, because there just wasn't much top end to save here. So then we went and talked to the water safety folks, and the answer there was they already had a solution, so they also were sending out to a lab. And for the most part, none of them had any money. They couldn't buy an instrument, and when we described it to them, they said, "That's fabulous, we would love that, but there's no way that we're going to come up with $50 for that, let alone $5,000 for that. It's just not possible. That's not available in our budget." So there was nothing to do there. In the life sciences, I knew something about flow cytometers. Jen and Colin didn't, so I explained it to them. I had purchased a flow cytometer for my first company. I ran an immunology group at the company. My wife is an immunologist. She was actually the first person I did market research with. I came home and I said, "Honey, what would you think if I could give you a flow cytometer that worked as well as a fax caliber, about $130,000, but would cost maybe like $15,000? And you might imagine what her response was, but I can tell you exactly what it is because it's seared in my mind. She said, "I don't believe you. But if you could do it, I want one." And we started talking to folks, and we got the same answer from about half the people we talked to, almost exactly the same. "I don't believe you." But then they started pounding the table. "I want to be first in line to test this product. I need this product right now. When can I get this product?" People were standing in line for shared equipment. Flow cytometers are expensive. Most laboratories cannot afford to own their own, so they're using them in a shared context, either in a core lab in a department or in a core lab for an entire facility. They're frustrated. Turns out we learned that they were frustrated with the current products. I know I was frustrated with the flow cytometer I bought. It was very touchy. Actually, if you touched it, it stopped working. It was very expensive. We had to have an expensive service contract that went along with it so that every time you touched it, the service engineer could come out and fix it. Folks had a lot of budget constraints and high expectations. They could afford a lower cost instrument. They could not afford any of the instruments that were on the marketplace for the most part. So we decided that there was actually a market for an affordable, easy-to-use, high-performance flow cytometer. All the words in that statement are important, and I'll explain that a little bit more. We are going to look at this wheel of fortune again in classes as we go forward. But we started out with working on a concept that we'll call a value proposition. The value proposition here is that people want to use flow cytometers, but they can't own flow cytometers. And the problem is that the flow cytometers are too expensive, too complicated, too large, and that if you could replace that, then folks would actually come and buy them. That was our proposition. That was our hypothesis. That's another way to think about this. So we start with a hypothesis, and then we tested it. We went and did extensive customer discovery. And after we'd go out and talk to folks, we'd come back, compare notes, think about what we'd learned, and then head back out and ask more questions. And then we would, the term's overused, but pivot, change. So from the value proposition, as I mentioned, this is really a hypothesis, and then we can frame it in this way. So customers have a problem, and the proposed solution is better than the alternatives, and that results in a compelling value. So that is a statement. We made that statement. We filled in who the customers were. They're life science researchers. Their problem was they couldn't afford flow cytometers. They had other problems with flow cytometers. A smaller, lower cost, easier to use flow cytometer would be better than the alternative of waiting in line, and that would be compelling enough that they would use their budget, available budget, to buy one. We had to test that hypothesis and determine whether or not it was true. So, just to kind of go a little more detail on that, customers here are life scientists. We also had thought and had talked to folks about clinical use for the flow cytometer, which was thought of as potential, but not something we were going to start with. Their problem was they couldn't afford an existing analytical flow cytometer, and we'll actually look at the price curve in a minute. It's too expensive for most labs to buy, and it would be too expensive for most labs to own, because these are big, expensive pieces of equipment. They actually have to be installed. When you buy one, they come on a pallet. They sit on the pallet until the field engineer is available and until you have the bench specially engineered so that it can handle the weight of the flow cytometer. Then it's installed by the field engineer. Then the field engineer goes away and comes back tomorrow when it stops working, and then comes back every week when it stops working, and then does service on it. And because of that model, that turns out it's very expensive to own one of these instruments. So even if you could afford to buy one, the upkeep is very high. Okay? So they turn out to be too large to fit in a lot of labs. As you probably know, anybody who's worked in a research lab knows that square footage is difficult to come by, and labs tend to be crowded places. And an instrument that was about half the size of a refrigerator was difficult to find a place for. Okay, so I have to say, I spent a lot of time talking to investors about this concept and trying to explain to them why this was a compelling opportunity. And most folks that we were talking to on the investment side had no idea what a flow cytometer was or why we were talking about this. So I ended up having to explain to them. I said, imagine if every car in the world cost $130,000 and was the size of a tank and required a pilot's license to operate. How many people would own cars? Very few, right? Until somebody was to come along with an automobile that was affordable, easy to operate, easy to maintain, and was good enough to get you where you wanted to go. So that's Henry Ford's approach, and we were basically trying to build the Model T of flow cytometers. So the solution here is an inexpensive, versatile, miniaturized flow cytometer for use in life science and drug discovery. Competitive advantages that we were working on is that we were going to produce industry standard capability and performance. It was going to be affordable to buy. It was going to be affordable to operate. It was going to be easy to operate. And it was going to be compact so that it fit. And the value that we were going to try to provide in the value proposition is that researchers would finally be able to own a tool that they use all the time. We expected to expand the market by hundreds of millions of dollars. So I personally talked to more than 80 interviews. And as I said, of those interviews, approximately 40 of them were, I don't believe you. But if you could do it, I'd like to. Do you need help? I'd like to sign up to be a beta tester. When could I get a hold of this? I have some room in my grant that I'm writing right now. Could I put it in there? This was years before it was available. Jen Baird said to me once, she said, we know we're on the right path because when we talk to the customers, they start pounding the table that they want the product. And I think that's actually a pretty good measure. You'll talk to folks and they'll say, yeah, that sounds like a good idea. That's a great idea. That sounds like a good idea. And we're going to talk in another class about why people say that even when they're, maybe it's not such a great idea. When they pound the table, they really mean it. And that's what they were doing. But to be successful, we really did have to meet all of those terms. And the reason we knew that to be true is that there was a company that had already written a business plan that looked just like ours. And in fact, they raised $67 million of investors' money and weren't going anywhere. And in the vernacular of the industry, they had essentially peed in the pool. So when we talked to investors, investors said, oh, that sounds kind of interesting. They did a little investigation. They found a company called Guava, and they found that this company had, on their website, it said the same thing. It's low cost, easy to use, miniature flow cytometer, and nobody was buying it. And when they asked people about the people that we said were going to love it, and they asked them, they said, well, why don't you have one of these Guavas? They're like, it's no good. We don't want it. So then they come back to us and they'd say, thanks, but we're not going to invest. So we had to figure out how to overcome this. The reason Guava wasn't getting anywhere was they had an easy-to-use product that was at a low price. It was a low cost to own, and it was small, but it did not have the performance that was required. So for those of you who have used a flow cytometer or done a lot of work with fluorescence, you know that 488 nanometers is a magic wavelength. That's blue light, and a lot of our reagents require blue light in order to do fluorescence. And blue light was expensive to produce. So Guava had figured out how to make a flow cytometer that used a green light. And they could make green light, they could get a diode producer of green light that was inexpensive and small and made their instrument work. But that meant that about half of the reagents that people were expecting to use, they could not use in this instrument. So from their perspective, it was nothing but a cell counter. It wasn't a flow cytometer. And that was the problem with that instrument. So we knew we needed to hit all of those 5 items. That's where the magic was going to be. And I'll show you, this is adapted. I actually made this slide to show to investors. I've stripped out a lot of the names that were on this slide. But each one of those circles represents a product that was on the market. And as you can see, they're across on a scale of price, and then I have a relative scale of performance. Now, that's a relative scale because at the top we have cell sorters and specialty instruments. At the bottom we have analyzers, and at the very bottom we have cell counters, right? But you can see there's a linear relationship between what that instrument can do and what that instrument costs. And where folks really wanted to be was at the high and towards the top dotted line, analytical flow cytometers that had 2 lasers and multiple detectors. But they could really only afford towards the bottom of the dotted line, the bottom dotted line. So we were going to break that curve, right? We were going to produce a product that was lower priced but could do the same thing. Now, we got a lot of pushback from prospective investors on that as well. There's a general rule of thumb that says don't try to win on price. Not that having a better price for a product can't be helpful for you, but from an investment perspective, if you're going to start up a company and you're going to do it because you can do things at a lower cost than your competitors, chances are your competitors will just lower their costs and they'll sell you out of the marketplace. So investors have learned that for the high-risk type of venture investing, just doing things on price is a bad choice. But we weren't just doing things on price, but we were able to lower the price sufficiently that we were enabling. And that was very important. So I had to draw this curve too. And this is a price sensitivity curve. So the line traces, I would buy this product if it was at this price, or I could buy this product if it was at this price. And it turns out if the product is free, everyone can buy it. Okay? And if the product is really, really expensive, almost nobody can buy it. And when we have this curve, it turned out there are reasons, if you look at the way NIH grant budgets were working, there were reasons why it was difficult for folks to get purchase products once they got over 20, 30, up to $40,000. That was very difficult. You could take an R01 and you could put some stuff in the budget. You could stitch together a couple of labs that could go in on a product together. But once things got over that threshold, basically labs dropped out. Now, we heard from a lot of investors after we explained how great our product was, and we showed them that the competition was really expensive and we were just as good or better than they were, and we were going to be selling at a lower price. They said, well, you're crazy. If you're better, you should be selling at a higher price. And then I'd have to show them this slide and say, well, we could sell at a higher price, but then no one would buy it because there's no one who has any money to buy. In fact, the folks who are going to buy probably already have bought. And the only way we would succeed in that is if we were a company that could be manufacturing these large devices and had an engineering force all over the place that could support the devices and was available. There's engineers that are basically waiting in the parking lot at the University of Michigan to treat the flow cytometers every day, and we'd have to have a company like that. That would be a very big company and it would have to have a large footprint. 65% of the market was owned by BD Biosciences. Another 25% of the market was Beckman Coulter. Those were the only companies that could actually manage to manufacture and sell and support the products out on the end. So we explained that what we had was a captured audience, trapped. These were customers who had money and they wanted to spend it, but they couldn't find a product they could afford. So the end of the story, looking at the time, the end of the story is that a company was formed. We licensed it. It was Accuri Cytometers. We launched the product. The product was successful. And eventually that company was purchased. So there are some things that worked and as predicted and some things that were unexpected. So Accuri Cytometers was active from 2005 to 2011. And the things that happened as predicted was there was a lot of customer enthusiasm. We had fast revenue growth. Revenue growth was about 3x per year. The 5 keys to the value proposition that we knew we had to hit were in fact the only things that kept that growth going. So the team's vision was correct. We knew that if we could make it, they would buy it. And they did. We did have an early exit opportunity. In fact, we had an opportunity to sell the company as soon as we introduced the product to the market before we'd even sold a product. And eventually the company was acquired for a lot of money, which we promised our investors it would be, and it was. So what's unexpected about this? The product launch took more than a year longer than we thought it would. That's actually to be expected, but we expected a year and it turned out to be 2 years. It was hard to achieve the margins that we needed to get. We could not sell it for $15,000. We could not sell it for $25,000. We ended up having to sell it for about $30,000 and up, depending on how it was configured. Another thing that was a surprise was the product that we sold was 100% invented after the technology left the University of Michigan. So we had the idea at the University of Michigan and we had a prototype that came from the University of Michigan, but in order to finally make it work and get it out the door, we had to keep reinventing, and by the time we were done, there was nothing of the original left. So all of the IP was actually created at the company. The team's vision was as expected, which was a surprise, was that the team turned over early on. And that actually turns out to happen a lot in life science companies, or in entrepreneurial companies as they grow from very small, 1, 2, 3 people, to growing to 30, 40, 50, 60 people. There are sweet spots in there where people work in their sort of an ideal environment. We used a lot more investment than we thought we'd need to in order to get to exit. It took more than $30 million of investor dollars. But the good news is we were acquired for $205 million by BD Biosciences. This was also a surprise because I had been telling investors, and we had all agreed that the company was definitely going to be bought, and it was going to be bought by a company that wanted to compete against BD Biosciences. But BD's Biosciences would definitely not be the company that bought us because they sold Cadillacs, and this model, the Model T, doesn't fit with their selling Cadillacs. So if you go to a Ferrari dealership, you're not going to find Toyota Camrys. So we just said that they won't do it. It turns out that if you, the way to get acquired, there's two things that drive one company to buy another company, and that's fear or greed. And we had several companies that wanted to buy us for greed, and they didn't come up with nearly the price that the company who had fear was willing to pay for us. So BD Biosciences recognized that we were going to eat their lunch, and so they bought the company. So they now sell this product. They haven't done the greatest job of growing that product, but that's typical for large companies. And but if you go to the website and you look at the product, you'll see the product that we build, and they talk about it as it's good. It works better sensitivity. It's reliable. It's capable. It's easy to use, easy to maintain, easy to teach, compact, transportable. Basically, all the things that we said we were going to be able to do with this. And in fact, it even grew the market. So it's the most cited personal or small analytical flow cytometer in the marketplace. And lots of people who couldn't use flow cytometers before use flow cytometers because of this product. So that's the end of the case study. This is almost everything that we talked about in here we're going to have a class on. So we're going to go over value proposition. We're going to go over pitching to investors. We're going to go over intellectual property. We're going to go over how companies are invested in and how they go through exits. So all the elements of here we're going to have a chance to talk about in future classes. I'm happy to take any questions. Yeah.
So I thought it was kind of interesting that so there's an innovation grant to develop this new technology, and you described that there was an observation, unmet need with bacterial contamination, but based off of what you described later, it didn't sound like they'd done a lot of market research to really assess whether or not companies would be willing to invest in it. Is that
Sure.
a typical type of...
I will say that most of the projects that fail, probably about half of them fail because of a fundamental flaw in there's basically a fault in the company from the very beginning, and the fault is there's something wrong with the value proposition. People don't actually want that product as much as someone thinks they do, or the product that they want is not the one that the company's trying to build, and that's why we're going to focus a lot on value proposition. It's not uncommon at all for technology that's being developed at the university that's envisioned to go in one direction to actually end up going in a different direction. And it's a normal part of the process for that to be a learning exercise that takes some time and it takes some energy. And one of the things that I want to talk about in this class is what that looks like so that you can recognize what a good value proposition is when you see it, and you can actually test it and figure out whether it makes any sense. I will agree that there were some assumptions made about this was really going to help environmental health and safety that were actually not supportable. Just didn't go in that direction. Fortunately, the idea of failing early, that idea failed relatively early once we got entrepreneurs involved in the project. Yes? Yep.
My understanding from the customer discovery phase is you don't necessarily disclose the entirety of your product.
Mm-hmm.
You're sort of having them, you're being vague and then having them verify kind of the need. So could you just talk more about that?
In another class, I will. In fact, I'm going to talk about it a lot. There's basically two kinds of customer discovery interviews that you can do. One is to say, here's a product, what do you think about this product? The other one is to say, tell me what you do in your life. What things make you happy? What are the frustrations? Don't tell them anything about your product or whether or not it's going to solve that problem. Just ask them what their problems are, right? And we did both. Eventually, we said, okay, what would you think of a product like this? Because the investors wanted to know what people thought of a product like that. That's when they started pounding the table. Yes?
I have a question about funds. So how do you get the seed fund to fund the stock?
Yeah, well, there's a lot to talk about there. In this case, actually the seed funding before the company was even formed came through the university from the state of Michigan through a university commercialization fund. And that was the money that we were able to use to engage Jen Baird and Colin Rich to come in as entrepreneurs to look at the idea, determine that some of the ideas about the market weren't correct, and that there were other ideas that hadn't been explored. After that, what Jen did was she basically built a business plan. Every business plan starts out somewhere, it ends up somewhere else, but that business plan is what you starting your first conversation with investors on. So once we had a business plan put together, I introduced Jen to an investor that I knew and a mentor of mine, and I said, let's take this business plan to him and let's ask him whether he thinks that this is an investable business plan. He's looked at lots of business plans, and he would probably know whether or not one looks good or not. He said it looks good and I want to invest, which was a bit of a surprise. That was not typical. You don't typically get investment from the first investor you talk to, although it has happened more than once to me. So that's how we did. It's a bit of bootstrapping. It was a bit of finding some resources that were available through the university, through the state of Michigan, cobble together some market research, assemble the beginnings of a business plan, take that out, get some feedback from investors. We were lucky we struck interest very early on. And the investors put some money in, and then some other investors put money in, and it grew from there. But we'll get into more of how that works later as well. Yes?
How much influence do you think the investors have in the process?
Investors typically have a lot of influence on the process. And that can be good or that can be bad. And I have had plenty of experience with both. In this case, the investors had a lot of influence in the diligence of the work that we did. So the 80 interviews that I did, I was willing to stop after 20 because I knew what the answer was. They weren't satisfied with that, and they wanted us to go out and do more interviews. So we did more and more and more interviews. I will say that we learned more about the product and we had a better understanding of how people use the product, and that easy-to-use component of the product was better fleshed out as a result of those interviews. There were other elements. Investors get anxious. Investors get bored. There can be a distraction that happens in the company because of investors want to go one way or go another way. Have investors that have disagreements amongst themselves about the best way that things can go forward. That tends to sap energy out of the company. So you need to be careful about who your investors are, and if you get good investors, it really makes a great difference. They can provide both experience and wisdom to the company. Other questions? Yeah.
First of all, it was a great and really informative talk, so thanks so much. I'm struck by the timeline of how this process unfolded. So the idea originated like 2001, and then I forget if the patent was 2005, and then it just it's like a tree growing. That it took some time to develop the roots and then to see the flowers. Is that a typical timeline? And so, should one of the goals of this process be for us to grow in patience?
Yes. So I will say that it's not surprising that a company that has seed funding is exiting after 4 to 6 years. Okay, maybe I'm wrong. That's an angry investor. You should have exited in year 3. It is that's not an uncommon timeline. And it's not uncommon that it took a couple of years to get out of the university or more. In our case, the idea was there was the sort of light bulb was going off in 2000. The patents were being filed in 2001, 2002. I ran into the project, and the other entrepreneurs ran into the project the end of 2003. Business plan was being developed. I tell people that if they can get a business plan turned around in 6 months, that's remarkable. Typically, they take a year. In this case, it took us about, we were talking to investors at about 6 months, but the business plan was still being developed. It took from when we started working on the business plan to when the company opened doors, that was about 13 months. That's pretty good, actually, in the life sciences. Now, things are if we're talking about something in the digital space, different story. You have different sort of. We had to build prototypes. We had to put together an engineering team that had to actually solder things together and figure out that didn't work. And there was a lot of manufacturing by hot glue, and so that takes time. So those timelines are not unusual. And then we launched the product. We announced the product to the world at the end of 2006. So the first prototypes were out in 2007. So that was 2 years after we launched the company. That was longer than we wanted it to be. We thought it was going to be a year or less. As I said, we missed that by a year. Most investors will tell you, with their wisdom and experience, take whatever number the entrepreneur tells you and multiply it by 2 or more, and that's probably what's going to happen. And that's exactly what happened to us. And then in this particular space, and we'll touch on this a little bit, in the medical, or in the life science tools space. So this we'd consider this a tool. As this device has been applied to diagnostics, then it becomes basically considered a medical device. But in both of those markets, companies tend to be acquired based off of the success they have in the marketplace. That's different from a drug startup. A drug startup, you're going to be acquired based on the success you have in your clinical trials in phase 1 or phase 2. In this space, you have to get the product out there, and people will believe you when other people send you money, basically. So we had 3 years of sales, and before the company was purchased. 3 years gives you a line. Go ahead.
You had mentioned your IP was all developed after leaving UM. How did that relationship and royalties work?
Yeah, so that actually changed the way things are done at the tech transfer office a little bit. So the university had given rights to the patents to the company in exchange for royalties back. The university did make some money back from the company as it was paying fees to maintain that intellectual property until the company was no longer maintaining the intellectual property, didn't need it anymore. And at that point, the university got the IP back, but didn't do any good. So ultimately, the full success of the company was not, the university didn't get a chance to participate economically in that. There were a lot of other benefits to the university, but yeah. Another way to have a relationship with a startup company that comes out of university is the university takes equity in the company, so it takes ownership of a portion of the company in exchange for rights to use the patent. And in that case, and when the company's sold, they get money. And it doesn't matter whether the company's still using their intellectual property or not. University of Michigan, I think, has developed some really best practices around basically, in most cases, taking both, taking a royalty and taking some equity, hedging their bets, as it were.